Right, let's get started on this one. Now, I think some of you know already what a pendulum is. Yes? But I wonder if, for example, Ming knows what a pendulum is. Ming? Do you know what a pendulum is? Great. Okay, let's see. No dictionaries. You don't know either. I'm sure Kei Hong knows what a pendulum is. But does your friend beside you know what a pendulum is? Do you know what this is? No, okay. Right, so let's see. And Jason? Do you know what this is? Ah, good, okay. I'm picking out the right people who don't know it. Now, I bet Aoife knows what it is. Oh my goodness, I thought you would know what this is. I'm shocked by this. You know, Marwan? Oh, really? Well, that's what I want to know, if you know what the English is. Okay. And you don't know either. I'm shocked by this. Okay. So I'm sure, David, you know what a pendulum is. I know you do. You do know what a pendulum is. So, to the many people who don't know what a pendulum is, what is it?
Like a ball suspended
Yep.
from the short stand.
Yep.
And when it moves,
Yeah, can you give an example of something in the house, in the home, that's like a pendulum? Like the clock. Yeah. So a pendulum is just something like this. Yeah, like in a clock. Yeah? Okay. So, okay, you need to remember that word. Now, this lesson is important for your labs. Yeah, because next semester this will be one of what? I know. This is the... NCUK have a list of experiments that you can do. And I have to do, as a minimum, well, a few of them I have to do as a minimum. So guess which ones I picked to do. The easiest ones or the hardest ones? The easiest ones. Because... for two reasons. One, I want to give my students the best chance of writing the lab report. And two, the hard ones tend to also be the expensive and dangerous ones. And dangerous. There's nothing expensive or dangerous about a pendulum. Right? Exactly. Unless you swallow the string and ball or something like this, you'd be okay. Yeah. Right. Now, these are the names of the part of the pendulum, which you should write down. We don't consider there to be any friction. Although we do know in real life the pendulum will slow down.
What are the experiments we're doing?
I haven't 100% decided on it, but from the mechanics part of the course, the two I think I'll do is, one of them will be the pendulum, and the other one is the free fall experiment, where you drop something and you time it, how long it takes to hit the ground. Which one?
Oscillation.
Yep, for the pendulum. Yeah, oscillating motion. Okay.
Which second?
No, okay. Yep. Continue? No? Say again? After this. Massless.
Massless.
What about it? What does it mean? What, it doesn't have mass. Like, yeah, we don't consider the string to have any mass. Yeah? Obviously it really has a mass, but we imagine it doesn't. Okay. Continue? Yeah. Now, what I'm about to give you now is the proof of the pendulum formula. You need to write this proof down carefully, because in your lab report you'll need to give the theory, and so you'll need to copy the proof and carefully type it into your lab report. Okay, so you want to write this proof down carefully in your notes. So let's go through the proof now. So we'll just set it up. We have our pendulum here, and we'll say it has a length L, and at the end we'll have a mass M, and it's swinging in an arc, isn't it?
Yeah.
But what we'll do is we'll say roughly it's actually travelling in a straight line left and right. Now we know it's not really doing this, is it? It's kind of going down on an arc. But it's much easier if we imagine it like this, because what type of motion is this? No, simple harmonic motion, right? But this isn't really simple harmonic motion. We want it in one dimension. Okay. So next, I'll call this distance here to here. What did we decide we'll use? Well, let's use the letter S. And then we'll call this angle here theta.
Theta.
Okay? And I'll just write down sine theta equals S over L. And this length here is also L. Now, is it really L? No, in fact, it'll be a little bit shorter, won't it?
Yes.
But we're approximating. So we'll say cos theta is, and is, okay, so this is approximately, cos theta is approximately L over L.
Mm-hmm.
Yeah? Yes, Ming? Where's 2L? Yeah?
No, I was saying right.
This is, yeah.
It's the same length.
Yeah? It's okay? It's okay? Continue? Yeah? Okay, okay. Right. Next now, let's look at the forces. So what force do we have here? We have weight, which is mg.
Mm-hmm.
And then we can resolve it. This direction and this direction. Now look, this here is theta. Okay? So this force here would be mg cos or sine? Cos theta. And this one here is mg sine theta. But this is the one that's making it move to the left. And this one, all it does is cancel out the tension. So I care about this one because this is the force that makes it move to the left. Now, is it making it move exactly to the left? No, but again, we're going to approximate and imagine this is the situation we have. So this is the diagram. We have a mass here, m. We're imagining the t and the mg cos cancel. Now, see how I drew it on a vertical line? Is it really vertical? No. So it's very important that the theta is small. That's very important, because you want the pendulum to be as close to vertical as you can. So it's moving like this. In my picture, it's exaggerated. The theta should not be this big in the diagram, in the experiment. You want it to be more like this. Because if I calculate the force here and here, that's going to be roughly the same as like this. Roughly, isn't it? Okay. So, These two cancel, and you're just left with a force this way of minus mg sine theta. Okay, so let's look at Newton. F equals minus mg sine theta. F is ma equals minus mg sine theta. M's cancel. A is minus g, and what's sine theta? S over L. So now you have a little trick here. Let omega be root g over L. So if I was to rewrite this, it would be A equals minus what times S? Good. Now, where have you seen this formula before? Simple harmonic motion. Therefore, my choice of omega was correct. And using this as the omega, what do I get as the periodic time? 2 pi over omega. So, t will equal 2 pi root L over g. The omega is under. This is the formula for the pendulum, for calculating the time required for the pendulum to swing back and forth. Yeah? Yeah? The proof's a little tricky. The good news is the proof's not on the exam. All you need to do is type this proof up in your lab report. And if you're a little bit confused, there will be many, many websites online that have this proof too. Yeah? So, my next question. Suppose I replace the mass with a heavier mass. How will the periodic time be affected? What do we think? I replace the mass with a heavier mass. How will the periodic time be affected? Reduced? Not affected. Yeah, the formula doesn't contain mass, does it? So that means it's not important what the mass is. It doesn't affect the time. Now, what will happen to the time if I reduce the length of the pendulum? It will reduce as well. If I increase the length of the pendulum, it will increase. Okay? And then finally, the g is a constant. If you could change the g, if you did this experiment in high orbit where the g is smaller, what would happen to the t? If the g is smaller, what would happen to the t? The t will be bigger. Yeah? Okay. So, little question here. How long would it take a 1 meter pendulum to swing 10 times? Maybe you'll be more successful with your calculator this time. Tell me what the time is for this using the formula. Go to degree mode. What did you get?
20 seconds.
Yeah. Roughly 20 seconds. Yeah. No. See, no. Okay, is that one okay? Yeah? Right. Now, what I want to do next is to describe for you the experiment. So let's have a look here. So, describe an experiment to determine the acceleration due to gravity. I think this is our second experiment we've done, haven't we? We did one experiment before getting the centre of gravity. Do you remember that one? What do you do for that one? Do you remember how to get the centre of gravity of an object? Ah, come on, guys, wake up. Well, how do you get the centre of gravity of an object? Do you remember what we did? You hang it from... Yeah, and you draw the line, and yeah, okay. So now let's look at the experiment for calculating G. Okay, so what do we need? So the equipment is quite simple. You need a retort stand, string, a mass, like a ball bearing, and a stopwatch. The diagram. Oh, and also a meter stick or rule. The diagram. And then you have this here. So this is the mass, the string, the stand. Then you need your meter stick. And then you need your watch. Your stopwatch. Okay, so you'll need to also make note of this. So just write this much down, and then we'll have a look at the method, what you do. You got that so far? Yeah. How to what? Well, I have to continue now. Can I scroll down a bit? Yeah. So the method is, first, set up as shown in the diagram. 2, measure... Oh, thank you. Okay.
Are you okay?
Yes, just about. Measure. Oh, I think I have coronavirus or something. Okay.
Keep going.
Yeah, yes, stay away from me. Okay, so next now, measure the L to 1 meter. Well, maybe measure is the wrong word. It's really, if you want, maybe a better verb would be set the length to 1 meter. Okay? 3, time well. Set pendulum moving in a small arc. So just have it going a little bit. Okay? For time 10 periods. So time it to swing 10 times. Okay? And then 5, reduce L by 10 centimeters and repeat from step 3. So you go back to this step and you repeat everything but with a smaller length, and then you stop. Well, then you stop when there's no pendulum length left. Stop after L equals 10 centimeters. So 10 centimeters is the last one. Time it 10 times. This makes it more accurate. I'll explain now. The next step is the analysis. Can I scroll down a little bit to here? Yeah? Analysis. So, T10 is the time for 10 periods. But we don't want the time for 10, we want the time for 1. So what should we make T equal to? T10 over 10. You take your times and you divide them by 10. Why? Because there was 10 oscillations. Fair enough? Yeah. Now, have a look at the formula. It's T equals 2 pi root L over G. If I square this, I get T squared equals 4 pi squared over G times L. Okay. Now what I do is I plot T squared against L. So the graph will look like this. What shape will I get for this graph? Straight line, very good. And what will the slope of this graph equal? No? If you use this formula, 4 pi squared over G. Because this is like y equals mx. So by comparing, this is the m. Therefore, we're finished. Our G will be equal to 4 pi squared divided by the slope. Yeah. When you did this before, Dami, did you do the same graph?
Yeah.
Yeah. And you got the slope? Yeah. Has anyone else done this experiment before? Yeah. No? You've done it, Marwan? Yeah, that's what I usually see in physics books is 20 times, but that takes too long.
That's the exam. That's the exam, that's our standard exam.
20.
No, not 20, like I mean
Oh, the standard experiment.
yeah. That's like, these are one of the options that you pick from.
Yeah. The reason I do 10 too, well, one thing that's nice about doing 10 is I have the students do everything twice. So actually, I should have said that, sorry. you should do this step here twice. This is so you can make sure everything is accurate. Because if you do the same thing twice, then you should get the same time, more or less. So, actually we use both in the graph, but you could use the average if you wanted to. Yeah. Okay. Can I scroll down? Yeah. Okay. So, again, this is something that you'll have to do in the next semester. So you'll need to keep careful record of this so you can type it up later. Yeah. But that is the only formula in this lesson. So I'll let you try these questions for a few minutes. Let's see what time we're at. Yeah, just a few minutes, and then we'll start the maths lesson. Say again? No labs in semester 1, in semester 2. For essay in semester 1. What's an essay? What's the topic?
Yeah.
Be a physics essay about a physics topic.
Oh.
What topic? I don't remember.
Like I like physics.
No, not this. Definitely not this. I actually will give you the topics after the break. When you after the midterm break, we'll talk about the essay.
Okay. So when I spot, when I back to your essay.
We'll start the essay after the exam.
After the exam.
Yeah. We'll talk about the essay.
Okay.
We'll do the essay in stages, in steps. So we won't do all the essay in one go. We'll do it bit by bit. One part, then another part, then another part.
Okay.
Do you understand?
Yeah.
Okay. Try these questions for a few minutes. Roughly, yeah. But trust me, it's better than the essay. Yeah. Yeah.